So hello everyone, and today we'll be seeing one of the problem from Geeks for Geeks. It says palindrome linked list. Now the problem is pretty much simple that we are provided a head of singly linked list of positive integers. We have to check that if the given linked list is palindrome or not. That means if the linked list is of the fashion like this 1 to 1, 1 to 1, then it could be read from head to last and last to head in the same way. So that's what the palindrome is. Whereas in the second example, it's not a palindrome. Now we need to do this within O of n time complexity and O of 1 space complexity. So one thing which comes into our mind, and this is what node structure looks like. One thing which one can say that, hey, uh, I can just dump the linked list directly within an array. So, but that's not a very efficient solution because it would take a space complexity of O of n. What can we do then? Stack. Yeah, stack is a good option, but also stack would consume us O of n space complexity. Can we do better? Like if there was a way to just scan from left to right and right to left, both, and we could compare this part with this part. So can we do that? Yes, we could do that, but once we are having an iteration from right to left, let's say it is possible for you without using a array, then how are we going to store this? That's a good question. So instead of that, let's understand that, hey, can we break this linked list into two parts, like a b b a. This is a string, and if you break the string right from here, then we see that, hey, b b are equal and a a are equal. That means extreme ends, that means I 0 and 3 are equal, and so on. 1 and 2 are equal. That means if I have AB is equal to AB, or reverse of BA, that means I just wanted to reverse it, and that would be something like AB AB. And now I can check from this point and this point. So I can go only forward direction because it's a singly linked list. If it was a doubly linked list, then it would be very awesome solution, and very straightforward as well. But now I can just iterate from this point of A and this point of A, and consider that, hey, if these are equal, then I'm good to go. But in case if this is not equal, ABAC, then this is not a palindrome. Interesting. There are bunch of items we are doing here now. Let's note it down. We get the apt position to cut. That means midpoint. We cut on the midpoint. Second, we reverse the last last portion. And third, we restore the linked list. Again, prior to that, we wanted to do one thing, is check equality. So these 4 steps, the fourth step is necessary because we don't want that our function to alter the list and just not do this. This is not a very engineer friendly. If you are altering something, make sure once you are going out of the scope, you fix it. So cool. what I'm doing here is I'm getting the midpoint here, which is get mid from head. Let me take it into center. Nice, I have mid. Now what I'll do here is var or reverse the midpoint from the midpoint, and I'll say it as, it's not an int by the way, it's node. I'll take node rm is nothing but reverse mid. Sorry for the naming conventions, but yeah, I'll take a var equal. So we got mid. We are yet to implement it abstract way. We are yet to implement reverse, but we had made reverse hypothetically. We'll do equality is equal, I'll say, is equal of what, like head and mid or rm. Sorry. Now once we are done, we just go ahead and fix it. So fixing step is reversing it again, the mid portion. That is how we fix it, and return equal. Cool. So let's implement one by one. Get mid. Get mid is super simple. If you are unaware how to get the middle of linked list, click the video on here and you'll get to know in a very neat fashion. Node get mid. I'll just go ahead and quickly implement it. I'll have 2 pointers, node slow and fast. The slow is equal to fast is equal to node initially, while fast is not equal to null, and fast is next is not equal to null. I'm going to go ahead with s is equal to start next, and f is equal to f dot next. Then lastly I'll return s because that would be mid. Why? You'll get to know in this video. Now let's do a reverse quite node I'll say. Cool. So we have node as previous, which is null because we don't know, and neither we wanted to set it previous as the previous to this node. We have node as current, which would be node itself. I have in detail mentioned a very long way how you can reverse a linked list. If you're still unaware of it, click the video on your right and enjoy the detailed explanation with the logic. So it's a logic building exercise over there, and it's a fun to watch. I'll highly insist you to go ahead and watch it. So next is equal to current.next. Current is equal to current.next is equal to previous, just shifting the pointer. Previous is equal to current, and current is equal to next, temporary state. Return previous because current would be null, that's why returning previous. Now ultimately is equal is simple boolean is equal node n1 node n2. We are not concerned about size here because size difference would not be greater than 1. It can be 0, it can maximum be 1. So while n1 is not equal to null and n2 is not equal to null. How do I check this? Cool. I'm checking that if n1.data is not equal to n2.data. The data portion I'm checking, if it is not equal, I'll just return false. Because right from this point itself I came to know that hey, it is not equal. Maybe next nodes can be equal or unequal. For that I need to advance n1 and n2. n1.next, n2.next. Now I'm pointing to next pointers, and then I will check both of their data portions. until one of them finishes. If either of them finishes, I know that, hey, return true, because we didn't return false over here. It is ought to be true, as it has only size difference of 2. If the size difference was greater than 2, this function won't be working. So let's compile this for any compiler errors. There seems none. Let's try to submit this. Well, the time complexity of this approach is O of n, and obviously the space complexity of this approach. Okay, very fine. Why are you not working? It's not reverse of mid, it's reverse of rm, which would give you mid. Again mid. You don't want mid, you just want mid dot next, and here mid dot next is reverse. Let's try to check with this output. I don't want to do this silly mistakes, but yeah, again this is close to 4 a.m. So it's 1 1 1 1 1 and 2 1. This is not good. What am I missing here? Well, the reverse function can be ignored for now. I can check for mid. Fn f dot next is not equal to null. Sn f dot next. Okay, it's not dot next, it's dot next, because we are hopping 2 times, right? My bad. And once we are hopping 2 times, I don't want to do this here. Just making it clean and try to submit this one. Yeah, this was about it. I think rest all the test cases got passed with this one. The space complexity was the reason we didn't went with the simple approach of just storing it over here within maybe stack, maybe array. But we went with all this 3 steps procedure just because we don't want it to utilize any extra space as mentioned over here. These are the companies where this question has been asked, and with this thing in mind, it is a linked list question. For more such linked list questions, click the video on your right, and I'll see you in the next one.